All right, so I'm curious about your thoughts. Down on the check. So we're looking at this situation. To score the AP Statistics exam, ETS, which is a company, hires exam readers, table leaders, and miscellaneous other leadership. Each reading room consists of 16 exam readers and 2 table leaders. And there are 100 of those reading rooms. So in those 100 rooms, each room contains 18 people total, 16 readers and 2 table leaders. And then there's another room with 18 members of the other leadership working together. For a total of how many rooms?
30.
101 rooms. There's 100 reading rooms, and then there's one room that has this other leadership in it. So I'm curious, how could you design a stratified random sample of 36 people hired by ETS to score the AP Statistics exam? What could they do to do a stratified sample? Yes.
Pick random 12 members from each group.
Yes. Use the employer's role as stratus. Are you a reader? Are you a table leader? Or are you other leadership? Label all the exam readers from 1 to however many they are. Use a random number generator to select 12 unique numbers in that so that you end up with 12 exam readers. Then you would repeat the process with the table leaders, and you would repeat the process with the other leadership. So yes. What about a cluster sample? How could we do a cluster sample? We haven't actually practiced this one yet, but I'm curious what your thoughts are. I had you guys write down up above that cluster samples, we still have these groups. It's not the same as strata. How are the groups formed for cluster sampling? By location. So what kind of locations do we have to work with in this scenario? The rooms. How many rooms are there total? 100 rooms. How many people are in each room? 18 people are in each room. 16 readers, 2 table leaders in the regular reading rooms, or the 18 members of leadership. We want to get how many people total in our sample? 36. So if we let each of these rooms be our clusters, how many rooms would we want to select if we want to get 36 people? 2 rooms. Because remember, there's 18 people in each room. So let the rooms be your clusters, 18 people in a room. So we're going to label the rooms from 1 to 101. Use some kind of random number generator or names in a hat or numbers in a hat. You want to select randomly 2 rooms. And then you're going to go survey all of the people in those 2 rooms. What is a benefit for using stratified random sampling?
Someone from every group will be surveyed.
Yes, we have equal representation from all 3 groups. Equal representation from all 3 groups. What's another benefit that we saw yesterday on our graph when we did our dot plot? What benefit do we have with stratified random sampling over just simple random sampling, SRS?
Low variability.
Yes, it reduces our variability. What's a benefit to using cluster sampling? What is a benefit to using cluster sampling? I want you to think about if you were actually doing this. So if we did stratified sampling, we take all the people that are readers when they sign up and they check in for the day. We put all their names in a hat. We draw 12 names out. We do the same with our table leaders and the same with the other leadership. And then around lunchtime, we're trying to collect our sample because now we know who's going to be in it. You're going to be running all over the place. We've got 101 different rooms. You could have to go to all 101 of those rooms, potentially. With cluster sampling, what did we say we were going to do? Go to 2 rooms. Benefit of cluster sampling, it's quick. Cluster sampling is fast and easy. You don't have to label every person. We just needed to label all of our locations. And everybody that we need is in just 2 spots. Cluster sampling is better than a convenience sample or than a voluntary response sample. We're not going to see the same kind of like super high bias show up. Is it going to be as accurate as our stratified sampling? No, but when time and money is a factor, sometimes cluster sampling is the best option that we've got available to us. Sometimes stratified sampling is just not something that we can feasibly pull off. Right. I want to keep looking into these sampling methods. You guys remember our Justin Timberlake exercise yesterday? Let's keep rolling with like the same context. After you get this written down, I want you to flip to the next page. There's nothing on the back side of this, so you're going to flip to the next page. I think it's page 11. Although, for whatever reason, like 3 or 4 of these pages didn't end up labeled with numbers. All the rest of them did. I have no idea why. First thing I want to do is repeat our simple random sampling that we did. So I want you guys to take a new simple random sample of these 50 seats. One of the things you can do, one of the easiest random number generators, on your phone, if you just Google search random number generator, Google has one. For our purposes today, because this is kind of quick and easy, let's go ahead and use that one. I want to expose you guys to different types of number generators here. I'll pull this back up, but I want to show everybody. I'll pull it back up. So if I just go to random number generator, and I'm going to hit enter, Google has one right here for me. We labeled those seats 1 through what? 1 through 50. So here on the max, I'm going to change that to 50. And we wanted to pick how many seats? 10. So I'm going to click generate. It'll only give me one number at a time. So you're going to pick that one, mark it on your thing. Then you'll hit generate again. If it gives you a repeat, if it gives you a number that you already got before, just skip it and go to the next one. You want 10 unique seats. So I want you guys to do that. Pick out 10 unique seats, and I will bring around dots for when we get to that part. But for right now, just pick out your simple random sample of 10 seats and mark them. Are okay if I switch to the next screen here? So remember, on our simple random sample, you label random number generator for 10 numbers, and then we're going to survey the fans with the selected numbers. So like the first number that I pulled up on my random number generator, it pulled up a 50. So I would survey this seat, the 50th seat. And then when I hit my random number generator again, it came up with 13, so I would survey this person. You want to make sure that you have 10 seats selected in here. So this is seats 1 through 10. This is seats 11 through 20, 21 through 30, 31 through 40, and 41 through 50. You should have 10 little X's in here. once you have your simple random sample collected, we are going to collect a cluster sample. If you look down at method number 2, it says to make it easier to distribute the surveys, the promoter decides to pick one row and sample every fan in that row. He needs to randomly pick out that row. So on your random number generator, I want you to go in there and have it give you a random number between 1 and 5, because we're looking at the rows here this time. So use your random number generator. Have it pick out a random number 1 through 5. And once you know which row it has given you, you're going to mark all the seats in that row. So on my random number generator, let's see what it gives me. Go away. If I only want it to go 1 through 5. All right, so it gave me 3. So then I would want to select all of the seats in the 3rd row. You need to get your own random number. Not everybody should have the 3rd row here. What do you think of this method? Do you think it will produce good estimates? Why or why not? Why or why not?
I think that what people rate the answer will change depending on how close they are to the stage.
Yeah. What did you guys tell me yesterday your thoughts were as far as enjoyment level goes? Closer to the stage, farther away from the stage? Who do you think is going to enjoy it more? Yeah, like front row is probably going to get the most or have the highest ratings for their enjoyment level. 5th row, probably not as much per seat as the 1st row. So that 1st row is probably all going to give me an overestimate. If you got 5 when you did your random number generator, would you expect that to be an overestimate, an underestimate, or pretty spot on? Probably an underestimate. So I'm going to say no. Front rows will be overestimates. Back rows will be underestimates. If the promoter was really keen to use cluster sampling, is doing cluster sampling by row the best way he could go about it? Could he still use cluster sampling and probably come up with a better way of doing a cluster? What might be better for the clusters? He could do middle row, but then it wouldn't be random, right? What's a way that he could still keep this random in there, but hopefully reduce the fact that if he picks the 1st row, that's going to be an overestimate. If he picks the back row, it's going to be an underestimate. How could he account for that in picking what he's using as clusters? He could choose columns. A better approach to cluster sampling would be to use columns. Each cluster then would be, big word coming here, heterogeneous. Or same distribution. You got somebody from the front row, somebody from the second row, somebody from the third, somebody from the fourth, somebody from the fifth. So we have all of the rows represented in two different clusters instead of just getting one row. So same spread from each row. All right. One more type of sampling that I want you guys to do. We're still going to need your random number generator. I want you to go back and tell it to pick out a number from 1 to 50. So you're just going to pick out one number. We need a random starting point here. All right, so I'm going to pull up my random number generator and figure out what my random number is going to be. I want to go from 1 to 50. All right, so it gave me 40. I'm going to start with the 40th seat, which would be this guy right here. So pick your random starting point, mark it on there. And then we are going to go to every 8th seat after that. So with your starting location, from here now, since I'm at the end of a row, I have to go down to the next row to keep counting. So 1, 2, 3, 4, 5, 6, 7. Here's the 8th one, so I'm going to mark that. So if I've got 2 people, I want a total of how many? How many do we want in our sample? 10. So I'm going to keep counting. If I have to start back at the beginning, that's okay. So 1, 2, 3, 4, 5, 6, 7, 8. This one now. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. You're going to do that until you have 10 picked out. I've got 6 right now, so I'd still need to do it until I have a total of 10 X's on there. So every 8th seat, I'm going to put an X. Once you have 10 X's on this last one, you can stop. Of these 3 different sampling methods, simple random sampling, cluster sampling, this one is called systematic sampling because we have this pattern, we have this system every 8th seat. Which method do you think of these 3 that we've looked at right here is going to give us the best or closest approximation to the true mean? Simple random sampling, cluster sampling, or this one? Systematic sampling. Why? What are your thoughts?
It's all very spread out.
Yes. We're going to guarantee, since we're going every 8th seat, we guarantee that we get somebody from each row. We're always going to select fans that are spread out. and therefore should be more representative of the population. All right. So yesterday, after we'd picked out all of our samples, I had you turn the page over and we had the actual ratings from all 50 seats. And we calculated the mean or the average for each of these different methods. I want you guys to do that again today. So for your simple random sample, when you turn the page, I want you to mark the people that you used in your simple random sample. You're going to take the numbers that were selected from your simple random sample, you're going to add them up, and you're going to divide by what? You're going to divide by 10. I'll bring you around a red dot sticker. Over on the board, method number 1, simple random sample. That is where you will put your red dot sticker for this one. And you want to calculate the average for your simple random sample. I think it's so helpful to actually do the random sampling like this because I think you like simple, it's random, but I don't know if that's going to give you a really good approximation of what the whole field thinks. Do you want to calculate your average? The first one that we're doing is the one over here, method number 1, simple random sample. So your red sticker will go on this poster right here. So show me what you got. So when you add them all up, you should divide by 10. What happened when you added them? Oh, you're not adding up your seat numbers. These are your seat numbers. Those are the random numbers that it gave you. So you want to go find seat number 34. So here's 10, 28, 30, 1, 2, 3, 4. So this seat right here, and I'm going to find their rating. Does that make more sense? Yeah. Okay. So the red one is for sample number 1 for your simple random sample. You're going to do the same thing with sample number 2. This was your cluster sample. So you want to take the ratings for the entire row that you collected. You want to add those 10 values up. And you want to divide by 10. So whatever row you selected for your cluster sample, using your random number generator, you're going to do the exact same thing where you find the average. And I'm bringing around yellow stickers for that one. After you've done your simple sample, then I want you to do your cluster sample. Cluster sample will be the yellow sticker on the middle poster. And then there is one more average that you need to calculate, and that is the one from your systematic sample. Simple random sample was your red sticker. Cluster sample method number 2 is your yellow sticker. I'm going to bring around green dots for your systematic sample. Finished up before we leave today. You need another yellow one? Not a problem. Tons of yellow stickers. You're welcome. So as people are finishing up putting their dots on, I'm curious, remind me again, what does each dot on the plot represent? What does each one of those stickers represent? Yeah, the average from one sample that was collected. And so we have 22 different samples on each of these dot plots. And we calculated the average from each one of those. Cluster sampling plot. What stands out to you about the cluster sampling plot? It has a lot more variability than the other two. It also has seemed to like clump into some very distinct groups. What did we say we thought we would see from the front rows versus the back rows? Overestimates and underestimates. Since we're using the exact same audience data from yesterday, we have the exact same mean. I don't know if you guys remember yesterday, we said the true average of all 50 of these numbers was just a little bit over 78. It was like 78.38, 78.4. So the actual mean is about right here. We didn't get any values right there on our cluster sample. We had overestimates and underestimates, but we didn't get anything right here. Did we get close to the mean with any of our sample averages on our simple random sample? Yeah. Right here is the true mean. 78.38, 78.4 was the true mean. What about over here? Did we get there? Comparing our systematic random sample to the simple random sample. I'm getting my words confused here. Method 1 to method 3. I I do notice that we have a higher peak here, close to what our true average is. Which one of these is more variable though? Which one is more spread out? Simple random sample. We had values as low as 68 and as high as 86. Over here we have values as low as 72 and as high as 84. So it is shrunk in a little bit. We have less variability in our systematic random sampling than we saw in our simple random sampling. I want you guys to get sketches of these into your notes so that we can refer back to them later. But we're going to hold off on the important ideas until the beginning of class tomorrow. We're going to talk about some flawed situations tomorrow, and I apologize, we've run pretty much right up to the bell again. I do have the tests graded, and I am making sure to carve out time tomorrow to pass those back and look at them. I am so sorry that I have not put those back in your hands yet. But tomorrow we will finish up talking about our sampling. We'll have a chance to look at the tests, and we will also talk about problems or flaws with surveys. Very first homework is due on Thursday. I am still working on, so test scores are in Canvas, they're not in Skyward yet, so you can look and see what your score is if you want. I have not updated the homework grades yet though to reflect the 100% if you got a 70% or higher on the test.
Are you staying after? You still doing it?
I am staying after today. I have to leave right at 3 o'clock, but I am staying. Yes, sir.
Oh, so you haven't put the curve in yet?
The curve is in. Yes. It's just like I said, it's not in Skyward yet. It's in Canvas. I will be porting that over to Skyward super soon.